Good morning. I am still at jury duty. Hopefully, I will be back at the end of the week. I'm just not sure when exactly yet. So, we're just going to continue to play this by ear. Before I get into today's lesson, be certain that you are prepared for Thursday's quiz. Thursday's quiz, we will take whether I'm here or not. That quiz will be over the first section of your book, which was on points, lines, and planes, coplanar, collinear, all that kind of good stuff. And then the second section was on segments. So I would look over all the homework that you have on those. Look specifically at the ones that you've missed before, because if you missed it the first time, you may still be a little shaky on it. But look at everything and be prepared for that quiz. Today's lesson is on angles. Everything that we do is going to be made up of lines and angles. So we'll be using this all year long. So, and you know some about this from previous math classes. So an angle, this is the definition, is a figure formed by two rays, and those rays are called the sides, with a common endpoint called the vertex. So here's an example. I have two rays, ray LJ and ray LK. So the sides of this, I want you to add this to your notes, are ray LJ and ray LK. And that point that they have in common, that endpoint, is the vertex. The vertex is L. So when we're naming this angle, there are a couple of different ways we can name it. If there's only one angle in our diagram with a vertex at L, we can call it angle L. That's just saying the angle whose vertex is at L. And there's only one. If there's more than one, we can't do that. Sometimes there will also be a number here inside of the angle. This part of the angle is called the interior, the part between the two sides. So if there's a number in the interior, we can also name it that way. This symbol is the symbol for angle. It's not a less than symbol. A less than symbol looks like this. An angle symbol looks like that. One of the parts is horizontal. So angle 1. Now, we can also name this by thinking about how you would draw from one side to the other. So if I drew from J to L to K, other than the part that extends infinitely on, I have the basic parts of the angle. So I could name this JLK. One side, the vertex, the other side. Or the opposite way, I could go from K to L to J. And if I did that, I would be tracing the major part of that angle. Again, one side, the vertex, then a point on the other side. If there are more than one angles, if there is, more than one angle in the diagram with the same vertex, in this one, you can't call any angle angle R. If you say angle R, you're going to say, well, which angle with a vertex at R? Because there are several that have a vertex at R. So starting up here at the top, this angle that has sides RS and RT, so I'm going to add that onto this. The sides of these are RS and RT, and the vertex is R. Again, we start on one side, go to the vertex, and then to the other side. So SRT or TRS. The one down here at the bottom, its two sides are ray RT and ray RV, and its vertex is again R. we name a point from one side, then the vertex, then a point from the other side, like you were tracing it, T to R to V, or V to R to T. Doesn't matter which side you start on. You can start on either side. There's also the big angle in this that has the two smaller angles inside of it. The sides for that angle would be ray RS and ray RV, and the vertex is R. So we'll start on one side. I can go from S to R to the other side, V, or from this side, V, to the vertex R, to the other side, S. Again, you cannot call any angle R because there are three different angles that have a vertex at R. If you say the angle with a vertex at R, people are going to be confused. Now, in geometry, every angle has a measure between 0 degrees and 180 degrees. So there are three different types of angles. You did this in middle school. Just a reminder though, an acute angle measures between 0 degrees but less than 90 degrees. Some people remember it as acute. It's small, it's cute. If that helps you, fine. A right angle measures 90 degrees. And you may wonder, why do they call it a right angle? What if it pointed to the left? Well, the way it points is not what's going on. Another thing about right is not left and right, but correct and incorrect. When you're building something, if you're building a wall, you want it to be at a 90-degree angle to the ground or to the floor. So that is called a right angle. That is the correct angle, if you will. That's where this term came from, that it's correct if it's at a 90-degree angle to your floor. So that measures exactly 90 degrees. An obtuse angle measures greater than 90 degrees, but less than 180 degrees. So that's bigger than a right angle in terms of how far apart the two sides are. These two sides are further apart than these, or the acute angle, the sides are not very far apart at all. And then last, your book goes back and forth on this. At one point it says there is no such thing as a straight angle. Then in another part it says there is such thing as a straight angle. It's like they couldn't decide. A straight angle is an angle whose measure is 180 degrees. It forms two opposite rays. So in our geometry, all of our angles are going to be like that. When you get to pre-cal, you'll study angles that are bigger than 180 degrees. Actually, you'll do ones that are bigger than 360 degrees. But I'll leave that for your pre-cal teacher to talk about. Now, this is a picture of a protractor. Probably haven't used this much since middle school. We used some of these in our 7th grade pre-algebra class. So if we're trying to find the measure of an angle on here, and this is the way that the protractor is situated. If we're trying to find the measure of angle AXB, so one side is A, X is the vertex, B is on the other side. You can actually use either the inside scale or the outside scale. It really doesn't matter which. For this one, if we use the inside scale, A goes through 0 and B goes through, looks like it's 42. So we can just take 42 minus 0 is 42. Or we could use the outside scale. On the outside scale, ray XA, this side goes through 180, and ray XB, this side goes through 138. Now be careful, it's not 142, because this is between 130 and 140. So that's 138. So I could also do 180 minus 138 and get 42 that way. I think it's easier when something runs through 0 to use the scale that has the 0, and then it's just 42. All right, so then for the next one, angle AXC, A to X to C, again, I think it's going to be easier to use the inside scale. This is at 0. I'll just read over to here. That is 110 degrees. I don't even have to do the subtraction then. Or AXD, again, this runs through 0 on the inside scale, so I'm going to use the inside scale all the way around to here. That's 150. That is 160 degrees. For this next set, we're going to have to do the subtraction because neither of the sides runs through 0 degrees. So if we're trying to find the measure of angle DXC, and I'm sorry, I didn't explain this earlier, but you've seen this before. This little M in front of an angle means the measure of the angle. How many degrees is it? And if you forget to put the degree symbol, it's not a big deal. I don't always do it. Your book doesn't always do it. I'm not going to be too awfully concerned about that. So for DXC, I just need to decide whether I'm going to use the outside scale or the inside scale. It does not matter. I usually use whichever one is smaller. So I'm going to use the outside scale here. This runs through 70. This runs through 20. It'd be 70 minus 20 is 50 degrees. If I'd use the inside scale, this runs through 110. This runs through 160. 160 minus 110, also 50 degrees. So for CXB, I'm going to use, I'll show them both. So if I use the inside scale, ray XB, this side of the angle runs through 110. And I have to stay on the inside scale then. This runs through 42. So 110 minus 42, let's see, 110 minus 40 would be 70, so this would be 68. I could have also used the outside scale. On the outside scale, this runs through 138, and this side runs through 70. 138 minus 70, also 68 degrees. The subtraction on that one was a little bit easier. So if you look ahead and go, which subtraction would be easier? That might be another way that you decide whether to use the inside scale or the outside scale. For this last one, DXB, I'll just use the inside scale. So this is at 20. Excuse me, the outside scale. This is at 20. This is at 138. 138 minus 20 is 118. And if you want to, you can show how to use the other scale. You should get the same answer. Now, we had congruent segments. We will also have congruent angles. Remember that congruent objects are objects that are the same size and the same shape. So, congruent angles are just angles that have the same measure. So, if these two angles have the same measure, then the two angles are congruent. Again, remember, objects are congruent. So if you put your hands together palm to palm, you can show that your hands are basically congruent. But then when you're talking about equality, that has to be a measurement of some kind. In this case, the measure of the angle, or if you're talking about your hands, you might measure how long your ring finger is on each hand. Those would have to be equal to one another. So measures are equal, angles themselves, since their objects are congruent. Just like we had an angle addition postulate, we also have, a segment addition postulate, we also have the angle addition postulate. And it says this: if a point lies in the interior of an angle, then the sum of the measures of the two smaller angles is equal to the measure of the whole angle. So here, I've got two smaller angles and I've got the whole big angle. What this is saying is that the measure of JKL, so you can think about this as how far do you have to rotate to get from J to L? And rotational angles actually is a good way to think about this, and the way you'll think about it a lot when you get to pre-cal. And then from L to K to M, that is this much rotation, is equal to this much rotation, the measure of JKM. So it's the same idea as the segment addition postulate, where the two parts made the whole. Same thing here. These two parts are going to make the whole. So for this particular diagram, we're given that the measure of angle ABD is 37 degrees. I like to go ahead and write those on the figure. And I put it somewhere near the vertex in the interior. Now notice I made sure to put the degree symbol on it so no one thinks that that's angle number 37. It's 37 degrees. And the measure of ABC is 84. Now ABC is this whole thing. So the way I typically do it is sort of how we did it with segments, where we put the arrows on each end. This is 84 degrees. Well, the angle addition postulate tells me that the measure of the two smaller angles added together, the measure of ABD plus the measure of angle DBC, gives me the measure of the whole angle, angle ABC. Well, ABD is 37. DBC is what I'm looking for. ABC is 84. So I just have to subtract. If I subtract 37 from that, that's going to be 47 degrees. Again, if you don't want to show me this equation, at the very least, you would have to write this. The measure of angle DBC is 84 minus 37, which is 47 degrees. That's kind of a minimal treatment for this. I think this is better, but I would accept this as well. Again, in much the same way that a segment has a midpoint, an angle has what's called a bisector of the angle. An angle bisector is a ray that divides an angle into two congruent angles. So if ray MP bisects angle TMN, so TMN was this big angle, MP came in here and sliced it in half, then these two angles are congruent. And the way that we'll mark that is with an arc near the vertex from one side to the other. Notice I didn't draw these the same distance. If I do, it looks too much like just one arc. I want to have them offset just a little bit. That's how we show that these two angles are congruent, in much the same way that we did a little slash to show that two segments were congruent to each other. Okay, so let's take a look at a problem on that. It says ray BD bisects angle ABC, and we have no idea how big ABC is, whether it's acute or obtuse. I usually make it a pretty big acute angle when I don't know. You can make it obtuse if you would rather. I wouldn't make it a right angle because that's a very specific angle. So we've got ray BD that is in the middle bisecting angle ABC. Doesn't matter if the A is on top or on bottom. C's got to be on the other side. And since this is a bisector, we know that these two angles are congruent to each other, which means they have the same measure. The measure of ABD is 5y plus 15. The measure of DBC is 8y plus 3. I know that those two have the same measure, so I'll just write an equation that says that. And yes, you must have this equation. If you don't have this equation, you will not get full credit for the problem. If it's on a homework and you don't have the equation, you don't get anything. You got to show me what you're doing. So I'm going to subtract 5y from both sides, that's 3y. Subtract 3 from both sides, that's 12. Divide by 3 and we get y is equal to 4. Notice I don't require that you show all of your intermediate steps in an algebra problem. Once you've set up the algebra problem, you have showed that you have passed algebra already. So the solving, if you can do it without having to write minus on both sides and divided by on both sides, please do. In fact, I would highly recommend it. Um, it greatly speeds up your work. You do have to be careful, but I think it's a good idea. Now notice it wants me to find the measure of ABC. Well, I wasn't given the measure of ABC, but I can find the measure of angle ABD is going to be 5 times 4 plus 15 is 35 degrees. The measure of DBC had better come out to be the same thing, so I don't technically have to do this, but it's not a bad idea. That's 32 plus 3, also 35 degrees. So then this whole angle would be 35 plus 35 is 70 degrees. All right, hope you guys are having a great day. Please remember to study for your quiz, which will be on Thursday on sections 1.1 and 1.2. That's all the points, lines, and planes, collinear, coplanar, all that, and all of the stuff on segments. None of the stuff on angles will be on Thursday's quiz. Have a great day. Hopefully I'll see you by the end of the week.